Welcome back to Pharma-info with Shubhashish. Now today the topic is because right now I am in the flow. Of completing the synthesis and all, the synthesis which are kept in the PCI syllabus and all. So today it is the Diazepam, right? Okay, it is the Diazepam that we are going to synthesize. Okay, we'll see the theoretical, or rather of course the practical approach in a theoretical manner, right? Okay. So let's just move to this particular topic and all. So synthesis of Diazepam. Diazepam is found to be a well-known drug, right? So it's a well-known drug and having diversified uses and all. Several clinical indications Diazepam can be given, starting from insomnia to psychosis, and then in general anesthesia, right? Of course, that is not a clinical indication, right? That is a process, okay, which is given or which is opted prior surgery and all, right? Major surgery, I should say, right? So so this is all about the uses of Diazepam, right? Uses of Diazepam. So the general category in which Diazepam belongs, then general pharmacological category in which Diazepam belongs is basically a CNS depressant, right? So it basically is depressing the CNS by acting on GABA receptor, and it is acting as a GABA modulator, right? And I have already uploaded a video on the ACR of Diazepam. There I discussed about the mechanism. Okay, it's not that in depth, but still I have discussed that one. And the ACR was discussed in an illustrative way, right? Okay, so this is all about the uses and all. Now we'll move to the structure of, okay, as we are doing on a regular basis. That is, first and foremost we have to deal with the structure, then IPC name, and followed by dissection of the entire structure to get some clues or to gather the clues, okay. And while optimizing or while exploiting those clues, we are just trying to fetch, we are just trying to develop what the different starting materials which are involved in making the Diazepam and all, making the any compounds and all, right? So now let's move to this the synthesis and the structure and all, right? So let's see that how the structure looks, right? Diazepam belongs to the chemical category of benzodiazepine, right? So benz means diazepine, both are found to be fused, right? So diazepam, diaza, right? Let's see that what this name, okay, what this name reveals, right? Okay, so diaza. So what exactly it is exhibiting is, so we have a diaza, that means two nitrogens, right? Two nitrogens, and moreover, apine. Apine means, this gives us a clue that a heterocycle is of 7 membered, right? So these are the two clues that we are getting. We have got, okay, 7 membered heterocycle, right? Het cycle, right? So these are the basic two clues that we are getting from this particular name, right? So now, on the basis of this clue, let us just write it down, right? Okay, let us just write it down. So this is like this. So with that we have got what? With that we have got the apine, that is 7-membered heterocycle. And the thing is that now it's pretty clear to you that we have incorporated both the nitrogens, that is two nitrogens, that too inside the ring system, right? So that means we can say these two nitrogens are found to be the part and parcel of this ring system, right? So now this is about your Diazepam, and from the chemical classification or the chemical class, we can already, or we have already gathered the information that it is the diazepine fused with a benzene, right? So we are mostly done with the template, right? Now what is the additional things that are there, right? So while dealing with that ACR and all, okay, definitely, though, if you just try to remember the ACR, it says that we have a particular group at 7th position. So if we start numbering from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, we have 9 different positions or locations, right? And in detail, an explanation was done, okay, in that particular video, which deals with ACR of Diazepam, right? Chalo. So in most of the times it is the 7th position, that is the 7th position is occupied with what? Halogen. And it is the chloro that is more in most of the viable benzodiazepine, you can find the presence of chloro, right? Okay. Now the next is we have a double bond here, unsaturated link, where 1, 2, 3, 4, 5. It is the fourth and fifth position that should have what, or that must have what? An unsaturated link, right? And you are not supposed to push it from here to here in either direction, right? You are not supposed to push it in either direction, right? Which eventually leads to the loss of activity and all, right? Okay. At position 5, we have an essential phenyl, right? Essential phenyl, and then a carbonyl group has to be inserted where at position 2, right? And here a smaller alkyl, and in case of diazepam it is methyl. So with that we are done with what? With that we are done with the structure of diazepam, right? Okay, chalo. Now the next thing is how the IUPAC name can be framed and all, right? Okay. So this is found to be the template. No problem in it, right? We don't have any problem, okay, with this particular template. So the template is what? The template is 1,4 bench diazepam. So the template is 1,4 bench diazepam. 1,4 bench diazepam, right? Apine means 7-member heterocycle, right? So we are done with the template. Now we'll see that what are the substituents that are there with this particular thing. And while dealing with the substituent, definitely we know that we have a rule of thumb that you should go for this alphabetical. You have to prioritize it on the basis of the alphabet, right? So we have substituents here. So we have a substituent here. We have a substituent here. We have a substituent here. What are those? This is a methyl. So that means it is position 1 having or is holding a methyl, right? Coming to this position 5, right? It is the fifth position that is holding what? A phenyl. So 5 phenyl, right? Accordingly, you have to arrange them, right? On the basis of their alphabetical order and all. Now, at 7th position, we have a chloro, right? We have a chloro at 7th position, right? So we are done with this, the substituents and all. Now we are left with what? A carbonyl group. You are not supposed to call it as oxo. Rather, we can call it as 1,4 bench diazepam 2-one. Actually, basically, this is diazepinone, right? On at which position? 2nd position, right? Now, one thing is that as per the IUPAC rule and all, which states that while dealing with an unsaturated point, first thing is that you have to put 2H then followed by 2-on. This is the ideal way of representing what? A position in a heterocycle which is occupied with a carbonyl group, right? So that means you are not supposed to keep it like 2-on, right? Prior to that, you have to put what? 2H, 2-on. And one more thing is that at position 1 and position 3, both the positions are found to be saturated, right? This is found to be alkylated. This one is not at all alkylated, right? So that means the earlier state of this particular area was found to be hydrogenated one, and this is also hydrogenated one, right? So this is hydrogenated, that is clearly visible to you, but this one is not hydrogenated, but earlier it was hydrogenated. Later on it has been alkylated, right? So that is why 1,3-dihydro. This is the additional thing that need to be incorporated while framing the IUPAC name of what? Bench diazepam. So as a whole, how this can be, assembled. So now we'll just assemble them all together. We'll just, gather them all together, right? Okay. Let us just present them at a stretch. So how it looks actually. So we have chloro, we have, we have this things like phenyl, and then we have methyl as well, right? So MNOP, so CMP. So C, M and P. This is found to be the order, right? Now before that, in between this CM we have H. H is, that is hydro, right? So how it goes actually, how the nomenclature goes. So like we have to start with 7, right? Because it is the 7th that is holding a chloro. Hydro, that is position 1 and position 3, right? And then methyl placed at position 1 and phenyl is placed at position 5. So accordingly we have to write like 7 chloro, then 1,3-dihydro. We have incorporated this also in this particular priority order and all, right? Chalo. 1,3-dihydro followed by 1-methyl, then 5-phenyl, then 2H. Why 2H? Because carbonyl group placed at position 2, right? So 2H, then 1,4 bench diazepam, then H2O. That's how this. This is something like this, right? Diazepam. So what can be done actually? Okay, to this. So this is the area which can be methylated, right? This is the area which can be methylated. So one of the primary area which can be broken down into pieces, right? We can separate both the things, right? Okay. And the other thing is that we can place these things. We can also place these things, right? Okay. Let us deal with this particular fragment, right? If this will get separated from this particular portion, right? So we are left with what? We are left with C double bond O, CH2 followed by N, right? Okay. And we say that this is the fragment which is having a resemblance with an amino acid called glycine. Yes, glycine, right? So if glycine is there, if we just try to complete the structure of glycine, it is something like H2N. This is the N terminal coming to the C terminal. Now, if I just try to introduce glycine in a system as such, there may be a chance that the reaction may not be carried out in a smooth manner. Why? Because the amino acid itself is in the form of a deuterion, right? So that means two ions, oppositely charged ions, make may cause some problem to that reaction, right? And for that very reason, we need to derivatize to what? The glycine. And for that very purpose, what we are just trying to make, we just try to make it like ethyl ester of glycine, then hydrochloride, right? So we have just completed this particular fragment, right? So we are done with this, we have got the one of the important reagent, right, which can be introduced here. So what is left in the process? What is left in the process? We have a double bond because the glycine cannot provide the double bond, right? That means the double bond has to be kept here, right? So, and we know that H2, that means one electronegative atom has to be there, right? Because, and we cannot, present the halogen, okay, by means of multiple bonds, right? So that means the electronegative atom, that is oxygen, should come here. Oxygen should come here, right? Oxygen will act with this particular thing, right? Likely to act, right? Now, as we have decided to separate this methyl from the structure, right? During fragmentation, we have seen, right? So that is why we'll just make it like this. We'll just keep it like this, H2. It is expected that one of the hydrogen definitely will react with C2H5O minus and leaving behind the one that we are after, right? That we are after. Now, so this is one of the reagent and this is the other reagent, right? These two are found to be the important reagent, right? Okay, reagents, right? So what is the name of this? As I said, don't forget to write. Don't forget. Always remember that. Please, भले ही आप intermediate का नाम लिखो या ना लिखो, starting material, the name of the starting material has to be written, right? So this is what? This is basically, as I said, this is basically ethyl ester of what? Glycine hydrochloride. And this one is what? This is basically, if we just try to forget this two or hide this two, this is nothing but PHCOPH. That is benzophenone. And it is the benzophenone that is holding what? Two substituents, where position 2 and position 5, right? So can we say that this is 2-amino 5-chloro-benzophenone? So this is this is the name of this particular starting material, right? So if the reaction will take place, the intermediate, the kind of intermediate that is likely to be formed here is what? Is like this. So N, definitely C2H5OH will go off, leaving behind NH, followed by C double bond O. Condensation took place already. CH2, N should should be connected to this particular things by means of multiple bonds, right? We have a carbon here. To that carbon, one phenyl is there, and this particular carbon is having a connection to the phenyl, right? So likewise, we have got what? Demethylated diazepam. Can it be called as demethylated diazepam? Yes, definitely. Why? Because in diazepam, what is the difference between diazepam and this? Only methyl. Additional methyl is there in case of diazepam, right? So we are left with what? The final step. Now, this is found to be the intermediate one, right? This intermediate has to be methylated. How this methylation can be done? Methylation can be done in presence of what? Dimethyl sulfate. That is H3 whole twice SO4. Right? If we just try to present it in a different way, how it looks like this: S double bond O, S double bond O. Then we are left with methoxy and methoxy, like this, right? So this is same thing, right? Dimethyl sulfate. And here we need to take one base, that is sodium, methoxide, right? So here basically we'll take a base called sodium methoxide. So dimethyl sulfate in presence of sodium methoxide, NaOCH3, right? What this will do? This will just try to methylate what? The first intermediate at position 1 to make it diazepam. Now we have got what? The final compound. It is the intermediate one that got transformed into the final compound upon methylation in presence of methyl dimethyl sulfate, that too in presence of sodium methoxide, and we have got our compound of interest, right? Okay, thank you. Okay. Other method is what? Suppose ki here also the same thing. So here we'll just take the methyl amino, and you have to make it like this only. You have to make it like this only. Okay. So this is what? This is basically, this is 5, right? So 5-chloro to methyl amino benzophenone, right? One of the starting mixture, you need to react this, because what is left in the process? I'll just make it like this, right? Because the nitrogen should be, this is for my convenience, right? Okay. What are the things that we need to incorporate here? A C double bond O and CH2 and a nitrogen, right? Okay. I just want to, I just want to complete this reaction in 2 steps, right? So definitely, I'll just aminate this portion later, right? Later. So I need to fix, or I need to merge this to this. How this can be done? That means I need to put one chloro here, a halogen, because this halogen will react to this particular with this hydrogen, okay? And the other end is another chloro. So this is highly reactive. The name of this is what? Chloroacetyl chloride. Chloroacetyl chloride. So with this chloroacetyl chloride, what will happen? The HCl will go off. The HCl will go off, right? So if the HCl will go off, what should be the product that will get formed? So NH, C double bond O, CH2, make it Cl only, because we have not aminated this one, right? We have taken only CH2Cl. Now we have with us C double bond O. Definitely we are not expecting that the Cl will interact with this oxygen, because both are found to be electronegative. So what can be done here? But we need to aminate this one, right? For the purpose of aminating this one, this is the additional reagent that you need to remember. The rest of the thing you can build on your own, right? So here the amination and dechlorination at the same time dehydration. These are the reactions, okay, that need to be carried out, because we need to incorporate one nitrogen, we need to remove the oxygen, we need to remove the chlorine, right? Okay, how this can be done actually? So now the reagent that has to be brought here is found to be hexamethylene tetramine, HMTA, hexamethylene tetramine, right? So we need to bring here hexamethylene tetramine. I'll just rub it off, right? Let me just bring that particular reagent with which the mission will get accomplished, right? That is what I told. It is the hexamethylene tetramine. How it looks? Hexamethylene, and let me just tell you this hexamethylene tetramine, right? It is having an use. It is having an use in your urinary tract infection, right? Urinary tract infection. Now, hexamethylene tetramine. How it looks? Hexamethylene. That means and tetraamine. So hexamethylene, how it looks actually. Okay, let me do one thing. Okay, so likewise I have just put the 6 methylenic moiety. Now I need to just merge them all together with what? With nitrogen. I need to connect them all together with the help of nitrogen, right? So that means I need to place the nitrogen here. So this is one nitrogen, this is another nitrogen, this is another nitrogen, and this is another nitrogen. So I am done with this amine and all, right? I have incorporated 4 nitrogen, which is supposed to be there, tetraamine, right? But the thing is that here there is a deficiency in the valency and all, right? Okay, so it has not been satisfied with the valency and all. So how? So that means I need to connect them like this, connect them like this, right? But let me tell you one thing, if you just make it more chemically relevant, don't write CH2 like this, right? Rather, you're supposed to write it in this way, H2C, because after all it is a carbon that will form a bond with this nitrogen. It's not that it's hydrogen, right? So same thing here also, right? So being a chemist, you should look after all these things, right? In order to make it presentable, in order to make it chemically relevant, this thing should be taken care of, right? So this is the one, this is the reagent with which what? With which all these things will take place. That is, the nitrogen got inserted and we have got what? Sorry, because we have taken methyl amino, that is why methyl amino should be there, right? N has already been methylated, right? So now the nitrogen has been incorporated in presence of what? Hexamethylene tetramine. So with that we are done with what? The making of diazepam. This is found to be the another method by which diazepam can be synthesized. Hope you have understood the fact and file that is there in the making of diazepam. Okay, if you like the video, if you really like the video, don't forget to press the like button, right? This is the usual thing that I need to tell, because because I am running a channel, right? So I need to be professional, right? So please and make sure that I am expecting you to put comments, right? Comments is not key. Nice sir, very bad sir, very good sir. It's not like that, right? I don't want any kind of adjectives and all. I just want some suggestions by which the lecture or deliverance, the presentation can be improved, right? So please spend some time in in assessing this particular session and all, so that you can at least come up with some comments, some constructive comments, right? Okay. Thank you very much. Thank you for your kind patience. Thank you.